All right, hello everybody, this is Mr. Spear. I'm going to be going over your test review. I'll just go ahead and solve these out, and you can watch them and get the answers and solutions and go back and check and see if you missed anything. Number one, let's balance it out real quick. How many K's do we have right here? We have 2. Look over here, we only have 1. Let's go ahead and write a 2. Now we have 2 CLs right here, need to put a 2 right there. That makes us have 2 H's right here, 2 H's right there, CO3, CO3. We're good right there. Let's label it aqueous, gas, or precipitate. These two are already labeled aqueous, KCl. Look in your sheet. You'll find that it is aqueous. And then H2CO3, look that up. You'll also find that that is also aqueous. Moving on. Number 2, let's balance this out real quick. Li2, we need to put 2 right there. That gives us 2NO3, 2NO3. Mg is good. PO4, that's good. All right, let's go and find this out. So these are already labeled for us, aqueous, aqueous. Lithium nitrate, we know that that is aqueous. Look in your sheet. The magnesium phosphate, that's actually a precipitate. Circle. So this is going to be 1, 1, 2, 1. Sorry about that. I will go ahead and do this. You do need to have the 1s visible. That is part of it. That's my mistake. All right. Finish and balance. Question number 3. Look, does bromine replace fluorine? No, it does not. This is all in your booklet. Just keep on looking it up. All right. Finish and balance this. So we're going to have, is potassium going to replace copper? Yes, it is. So look it up. You can find that potassium is cooler than the copper, so it'll replace it. Let's go ahead and write that out. So copper plus potassium sulfate. Sulfate has a charge of, let me go ahead and pause. All right, so we're on question number 4. Potassium just replaced copper. So what is the charge of sulfate? You look on your sheet, it's -2. That means you gotta have the 2 right here because potassium is only a charge of +1. Now let's balance this out. We got 2 potassiums here, so let's write a 2 right there. 1 copper here, 1 copper there. 2 potassiums and 1 sulfate. There you go. That's that. Moving on. Find the central charge. Find the charge of the central atom in bromate. Bromate is Br(O3), the charge of -1. So oxygen is always going to be -2, which means that now that we have 3 oxygens, that means we have a charge from the oxygen of -6. So if we want our final charge to be -1, and oxygen is, I'll write that out, O3 is -6, how do we get from -6 to -1? Well, that just means that the bromine is +5. Cl and chloride, the chlorine and chloride. Well, chloride is ClO2 with a charge of -1. 2 oxygens, so that means that we have O2, which is equal to -4. And if we want it to end up at -1, well, that means that our chlorine has to be +3. Moving on. Finish and balance. Label each compound as aqueous, gas, or precipitate. Circle the precipitate And show net ionic equation. Write NR if no reaction. Okay. Let's go ahead and balance this equation first. 1 Na, 1 Na, 1 CO, 1 Cl, OH. This is all balanced out. So 1, 1, 1, 1. All right, guys, so now let's label each compound. We already know that these two are aqueous. NaCl, well, that's going to be, you guessed it, aqueous. Now what's H2O? That's water. That's liquid. And that is actually a precipitate. We actually circle that. So anything that is not aqueous, so anything that's a liquid, a solid, or a gas, that is going to be a precipitate. So water right there in that reaction is our precipitate. Okay, this is double replacement reaction. Let's go ahead and start that off. So let's do lithium chloride plus iron nitrate. So Fe is a transition metal, so we don't exactly know the charge of it, but since it's lined up with chlorine and there's no extra stuff going on right here, since chlorine, we know chlorine's -1, and since there's nothing else going on with the chlorine in the iron, we know that the iron is actually +1 since they cancel each other out. So we actually have our equation balanced right now because we didn't have to add any numbers to it. All right, let's look to see what our compounds are. Let's label them. Lithium chloride, look that up. It is soluble. It is aqueous. Iron nitrate, let's look that up. Ah, that's also aqueous. That means that there is no precipitate in this reaction. All right, now let's go back and let's do all the net ionic equations. Let's see, we have Na, let's pull that down. That is +1 plus OH. We know that to be hydroxide. That's -1 plus H. We know H to be +1 plus chlorine. We know that to be -1. All right, that gives us a reaction of, we bring down the Na, that's +1 plus Cl, that is -1. And now since our H2O, that's the precipitate, we actually keep that together. So now, what do we have? Well, what's our net ionic equation? Well, is our Na in the final and our precipitate? No, it's not. Let's cross that out. Is our OH in there? Yes, it is. There's an OH right there. We'll leave that be. Is our H in there? Well, yeah, the H is right there. The OH plus the H give us the H2O. Is our chlorine in it? No, it's not. Let's cross that out. These definitely aren't a part of it. So our net ionic equation turns out to be OH -1 plus H plus 1 go to H2O. Since there is no precipitate in this equation, there is no net ionic equation that we need to do. So you're done with this question right here. Let's look at the back. I'm actually gonna get a new sheet here so that we don't look at all this extra stuff on the back. How many moles are present in 34 grams of copper hydroxide? Let's first find, well, we know how to do this. All right, so let's write our proper number right here, 34 over 1. Let's multiply that by 1 over. So that's our given number. That's 34 grams. Now what's our proper number for copper hydroxide? Let's calculate that out. I'm going to go ahead and do that right now. So 64 plus OH is 17 plus 17, and we got to do that twice. So plus 17 again. So 98. This is going to give us our moles. So let's see that. 34 divided by 98 is equal to 0.35 moles. That's that answer. Moving on, number 10. How many moles are present in 2.45 times 10 to the 23rd molecules of CH4? Well, let's just do that real quick. 2.45 times 10 to the 23rd for 1 multiplied by 1 over, what's the proper number of molecules? Well, that's 6.02 times 10 to the 23rd. This is equal to 2.45 EE 23 divided by 6.02 EE 23. 0.41 moles. Let's move on to our two-step problems. How many compounds are there in 24 grams of iron fluorine? Well, let's do that real quick. How many compounds? Okay, so let's do, this is our V formation. If you guys remember that, 24 over 1 times 1 over, what's the proper weight of iron fluorine? So go ahead and calculate that out real quick. Do 56. Fluorine is 19. We got to do that 3 times. So 56 plus 19 plus 19 plus 19. That's our proper number. And then it's asking for how many compounds. So what's the proper number of compounds? That's really easy. 6.02 times 10 to the 23rd over 1. Let's calculate that out. So 24 divided by 113 equals times 6.02, 23 equals how many compounds? Well, this answer makes sense. 1.28 times 10 to the 20. This makes sense, right? Because asking how many compounds are in 24 grams, we'd expect to get a very large number. Number 12, how many compounds are there in 450 grams of Na2SO4? Let's go ahead and write our given number out real quick. Times 1 over our proper number. What's our proper number of Na2SO4? Well, let's go ahead and calculate that up real quick. 23 plus 23 plus 32 plus 16 plus 16 plus 16 plus 16 gives us 142. We're asked for how many compounds, so that's just a simple 6.02 times 10 to the 23rd over 1. Let's calculate this answer real quick. 450 over 142 equals that multiplied by 6.02 to the 23rd, 1.91 times 10 to the 24th. All right, guys, a little bit of change of scenery, but we're going to keep on going. How many grams are there in 2.3 times 10 to the 24 atoms of silver? How many grams are there in 2.3 times 10 to the 24 atoms of silver? We're looking for grams, but we're given 2.3 times 10 to the 24. Let's write that out. That's our given number. Times 10 to the 24 or 1 multiplied by 1 over 6.02 times 10 to the 23 What's the proper weight of what we're asked? What's the proper weight of silver? Look on our sheet, we find that it's 108. It's going to give us our answer. Let's calculate that out. 2.3 times 10, whoops, excuse me, 2.3 EE, 24. That divided by 6.02 EE, 23. This number right here multiplied by 108. That gives us 413 grams. All right, guys, if you've noticed, for these two-step problems, right here, this first step that we always do, that's just giving us our moles. I want you guys to remember that. This right here is the calculation of how many moles there are in this problem, in each problem. Just something nice to know and something to remember. Three-step problems. More of these will be on the honors test. How many atoms of oxygen are 98.3 grams of aluminum hydroxide? So how many atoms of oxygen are in 98.3 grams of aluminum hydroxide? Okay, first, let's set up our problem. We have 98.3 over 1 times 1 over, let's find out the weight of aluminum hydroxide. So we're going to add 27 plus, that's 17, so we have to do that 3 times. 27 plus 17 plus 17 plus 17 gives us a final weight, or proper weight, of 78. And since we're looking for atoms, we got to multiply that by the proper number of atoms, 6.02 times 10 to the 23 all over 1. So let's see what this gives us. 98.3 divided by 78 equals that answer multiplied by 6.02 EE 23. That gives us 7.586 times 10 to the 23. But we're looking specifically for how many atoms of oxygen are in this. So what we just found was how many compounds of aluminum hydroxide there are right now in 98.3 grams. So if we're looking specifically for oxygen, well, how many oxygen are going to be a part of aluminum hydroxide? Each compound of aluminum hydroxide, how many oxygen is that going to be? Well, if we look right here, we see that there's 3 oxygen. See that 3? There's 3 oxygen for every single aluminum hydroxide compound. So we're actually going to take this entire number right here and multiply it by 3. We're going to multiply this entire thing by 3, and that's going to give us our answer. So, times 3 equals, well, that gives us 2.3 times 10 to the 24. That's how many atoms of oxygen are in 98.3 grams of aluminum hydroxide. Very simple, very easy, but it can trip you up. You just have to know what to look for. Okay, let's do this again. How many grams of sodium are in 7.6 times 10 to the 24 compounds of Na2O? So, let's see, what are we given? We're given 7.6 times 10 to the 24. Put that over 1. We're going to multiply that by 1 over 6.02 times 10 to the 23rd. How many grams of sodium are in 7.6? Well, this is going to give us our moles, and here's a really quick, easy step to figure out the grams. Let's go ahead and calculate the entire thing first. What's Na2O? Let's go ahead and add that up. 23 plus 23 plus 16 62. But we're looking specifically for sodium, and we see sodium right here. If there's 62 grams in each mole of sodium Na2O, well, and we're finding the moles right here, we can actually do a quick shortcut and just write the total weight of grams of the Na2 in each compound of Na2O. So we want to calculate Na2, we just do 23 plus 23, that gives us 46. This shortcut right here, 46, we're just strictly calculating the Na2 out of this compound. So let's do this real quick. 7.6 EE to the 24 divided by 6.02 EE23 gives us, and we're going to multiply this by the weight of Na2 when it's in 1 mole of the compound of Na2O. It's very important to remember that. Times 46. That gives us 581 grams. This answer makes sense, right? This is a really big weight, and that's because that's a lot of compounds right there. Let's go ahead and do a quick percent composition, and that's going to be the end of this. Okay, so what is the percentage of sulfur in sodium sulfate? So first, what we want to do when we see these problems, is we want to calculate the entire weight first. So Na2SO4. Let's figure that calculation out. Na2, so 23 plus 23 plus S, and that's going to be 32, plus O4, so 16 plus 16 plus 16 plus 16. It means our total weight is 142. So we want to find the percentage of sulfur in sodium sulfate. Well, how much does sulfur weigh? Sulfur weighs 32. Sulfur weighs 32. So if we're looking for percentage of sulfur in sodium sulfate, well, we quite simply just do 32 divided by 142, and that's going to give us our percentage. So 32 divided by 142 equals 0.225. We can round that up to 23%. That's it. That is the test review. If you have any questions, just go back and watch the video, find out the question that you're looking for, and just rewatch it until you get it.